yesterday we took a look at what happens with intersections inside the circle, on the circle, and outside the circle of the angle measures. What's happening to the angles that they make, what those like secants that intersect with the angles that they make. Today we're going to look at the actual segment distances rather than the angles. So our first theorem, when segments or when our chords intersect inside the circle. So two chords intersect inside the circle. So think, inside the circle, you just take part times part equals part times part. It's kind of all there is to it. So basically, if I look at AC here, I take AB times BC, so part times part, and I got that right over here, AB times BC, equals EB, or BE, whatever you want to call it, times BD, or DB, which is right here. So it's kind of part times part equals part times part. That's all there is to it. That's our first theorem. So when they intersect on the inside, basically part times part equals part times part. So let's go ahead and try that here. So taking a look, I'll deal with this first segment, DB, this first chord. Well, part times part. So I got 12 times 9, and I'm going to set that equal to, well, part times part on the other one, 8 times x. So piece times piece or part times part when they intersect on the inside. So 8 times x. And now it's just our algebra. So 12 times 9 gives us 108 equals 8x, and we divide by 8. And that leaves us with 13.54x. And there's no units with it, so just 13.5. So remember, intersection on the inside, just part times part equals part times part. Okay, that might confuse you a little bit and throw some expressions at you rather than just numbers and one missing length, but it's still the same rule. Okay, I got an intersection of chords on the inside of the circle. So I take part times part, so let's look at SQ. So part times part, so x plus 4 times x plus 2. But put these in parentheses, because this is some number x plus 4 times some number x plus 2 equals the other one, part times part. I'm going to start with the x times the x plus 10. X times x plus 10. So you need those parentheses, because we have to distribute. And in this first case over here, got to follow the FOIL, so x times x, x squared, x times 2, positive 2x, 4 times x, which is positive 4x, and 4 times 2, which is positive 8. And distribute on the other side, x times x is x squared, and x times 10 is positive 10x. And let's combine like terms if I can. If I look, I got a 2x and a 4x. So that leaves you with a 6x. So replace that guy. That's really a 6x. And now let's get rid of our x squareds, or get our x squareds to one side. So if I subtract an x squared over here, I have to subtract one here. It just gets rid of them. So I'm just left with 6x plus 8 equals 10x. I'm going to rewrite that so we can see it a little bit better here. Equals 10x. We'll get our x's to one side. So subtract this 6x over. And we're left with 8 equals 4x. Well, we can tell that x equals 2 in this case. And that's what it's asking for. Yeah, and originally it just said to find x. So x equals 2. Sometimes you might have to plug it back in and solve for a side distance. But we're done. Moving on. Well, we can get into the sword problem. This actually happens. This is how scientists determine lengths of organisms when they use a microscope. So let's take a look at this example. It says, biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. So the microscope has a diameter of 2. I'm going to write that in there. 2 millimeters for this diameter. It says, determine the length of the organism if it is located 0.25 millimeters from the bottom of the field view, round to the nearest hundredth. So if we take a look, this little piece right down here is 0.25 millimeters. Well, if we take a look at it, it's a chord and another chord, and they're intersecting right here, inside of the circle. Okay? Well, I don't know the length of the organism, so I could just call it x units. Well, if you think about it, if that's x, these chords make a perpendicular, don't they? Right? Because if I have a chord that intersects with the diameter, it makes a perpendicular. That was a theorem that we had back a while ago, which means it bisects it. So I know this is also x. So that should help me. I should be able to use my theorem that we just came up with. Remember, part times part. So x times x. So x times x equals the other part times part. So 2, oh, that's not 2, is it? 2 is the whole diameter. So what's just this piece right here? Just this piece right here. Well, it's 2 minus 0.25, which is 1.75. So I'm using 1.75 there, right? It's not the whole day, it's part times part. So 1.75 times 0.25. Okay, so just be careful there. And we got x times x, which is x squared, and 1.75 times 0.25 gives us 0.4375. Well, to get x by itself, the inverse of squaring is square rooting. Whatever I do to one side, I do to the other. So the square root of 0.4375 is 0.66143. It says round to the nearest hundredth, so we're right there. And it's in millimeters. Boom, there we go. The organism is 0.66 millimeters, okay? So that's actually used in real life. That's what scientists do to find the distance or the length of an organism. Our next theorem, well, we could have an intersection on the outside of our circle as well. Okay, this is a little different. It's not part times part anymore. This is different. So if we take a look, if we have an intersection on the outside, so I got secants that are intersecting at A on the outside, we take the outer part times the whole segment. So it's not part times part anymore. It's different when they intersect on the outside. So I got AB times AC, the whole thing. So AB times AC. And same thing with the other one. We set it equal to AD, the piece on the outside, times the whole thing, which is AE. Okay, so take the piece on the outside times the whole when it intersects on the outside. So this is intersects on the outside. So it's really outside piece, out piece times whole. So when it's on the inside, it's part times part. When it's on the outside, it's the outside piece times the whole. And we set it equal to the outside piece times the whole. So for example, right here, we have an intersection on the outside. So I got outside piece. Let's deal with EI here first. I got outside piece times the entire thing. So 8 times the whole thing. So it's 8 and x. It's not 8x, right? That'd be multiplying. I got to add, right? 8 plus x. So 8 plus x. Be careful there. If you go too fast, a lot of people are going to write 8x, and that's not right. That'd be multiplying. And we're going to set that equal to, well, outside piece, right? Because it's an intersection on the outside, times the whole piece. So 10 times outside piece times the whole thing. So 10 plus 24, which is 34. I just want to write that so we can see it. So let's go through and simplify. 8 times 8 gives us 64. 8 times x gives us a positive 8x equals, well, 10 times 34, let's replace that with 34 now, is 340. And we got our x to one side, so let's subtract that 64 over. And we're left with 8x equals 276. And we can divide by 8 on both sides. So x equals 34.5. And is that what it's asking for? Go back up top, it says find x. Good, we're good. So x equals 34.5. So just be careful on that setup. Intersection on the outside means outside piece times the whole. The same thing kind of works with a tangent, but there's really only one piece to consider. So we just take it times itself. So if I look at this tangent here, this JK, I take JK times JK, because there's no other piece to it. There's no other whole piece. It's just one thing. And then I'd set that equal to, well, the same rule. Since the intersection on the outside, I take outside piece JL times the whole thing JN. So it's consistent with an intersection on the outside. So this is also an intersection on the outside. But the only thing is, it's got a tangent as well. Okay? So if it was two tangents, I would just take the squares of both, right? I think we would notice that if we went through. So taking a look here, LM is tangent to the circle, find x, round to the nearest 10. So here we go, intersection on the outside, so let's follow that rule. It's kind of like outside piece times whole. So let's see, I got this big segment here, so I gotta take outside piece, which is x, times the whole thing, which is x plus 2, right? It's these two added together. So x plus x plus 2. Be careful here. So it's outside piece times that whole length. We'll simplify that in just a second. And we're going to set that equal to, well, it's really outside piece times the whole, but it's just a tangent, so it's really just 12 times 12. So 12 times 12, or I could write that as 12 squared. And now we can go through and simplify. Well, let's add these two x's together. So we got 2x plus 2 instead. And let's distribute. So x times 2x, which is 2x squared, and x times 2, which is 2x, equals 144. All right, so it's a little bit different now because my x squareds don't cancel. So let's take a look. Well, we have a second degree term here, which means that it's a quadratic. Well, what do we do with quadratics in algebra? We want to get it equal to 0. So let's subtract this 144 over, minus 144. So I got 2x squared plus 2x minus 144. And we want to factor it so we can solve it since it's equal to 0. Well, first things first, when we factor, we always see if I can factor something out. So let's pull out a 2. I can divide a 2 out of all these terms. So I'm going to factor out a 2, which means I divide by 2. So I'm just left with x squared plus x. And negative 144 divided by 2 is negative 72 equals 0. And really that 2 just kind of disappears because I could divide both sides by 2 right away. Well, when I do that, the 2's cancel, and 0 divided by 2 is just 0. So what am I left with? Just x squared plus x minus 72 equals 0. So when you factor it out, it basically just kind of gets rid of it for us, which is nice. Okay, so now since I have a quadratic with no coefficient in front of the x squared, I can just find factors of c that add up to b, or in this case, factors of negative 72 that add up to a 1, positive 1. It's the number that's in front of the x, so a positive 1. And factors of negative 72 that add up to 1 would be a positive 8 and a negative 9, right? Because 9 times negative 8 is negative 72, that's good. And 9 plus negative 8 is positive 1, so it works out. That's what I'm looking for. So I can write this in my product of two binomials, just like you did in algebra. So you got x plus 9 and x minus 8. So that means x has to be negative 9 and 8. But if I think about it, can I have a negative distance? Can I plug in negative 9 up here on my picture and have a negative distance? No. So I can't have a negative distance, so I'm going to get rid of the negative 9. That is not an answer. So it's just x equals 8. This is round to the nearest 10th. I don't even need to round to the nearest 10th. We're good to go. X equals 8. And that's everything I got for you. So dealing with the intersection. Remember, intersect on the inside, part times part. Intersect on the outside, outside part times the whole.